In the last segment, we named ionic compounds when given their formula. In this segment, we'll do the reverse. We'll write out the formulas given their name. It's very important to know both the symbols and charges of all your common monatomic ions and polyatomic ions when we're writing these out. Our first example is calcium chromate. Calcium has the symbol of Ca and a charge of 2+. Chromate has a symbol CrO4 and a charge of 2-. Remember, ionic compounds are neutral, which means all of the ions that make them up will always add up to 0. Okay, so when we're writing out a formula for a compound like calcium chromate, start out by writing the symbols and charges of both ions right next to one another. Next, look to see if the charges cancel out. In this case, calcium is +2, chromate is -2. +2 and -2 add up to 0. That means they cancel out. It means that we only have one of each ion in our formula. So my formula, calcium chromate, CaCrO4, and since there's only one of each, these parentheses aren't needed. So we can last rewrite this as CaCrO4 without the parentheses. Now, because the charges cancel, this is a 1-to-1 ratio, meaning you have one of each ion. The charges won't always cancel. In this example, sodium chromate, sodium has a charge of 1+, but chromate has a charge of 2-. Step 1, write the two formulas and the charges next to one another and look to see if the charges cancel out. These charges won't cancel out because a +1 and a -2 add up to just -1, not 0. So the next step is called crossing the charges. When the charges don't cancel, we cross the charges. That means I take the charge of the first ion and I make it the subscript of the second ion. I do the same thing with the charge of the second ion, making it the subscript of the first. So I end up with 2 sodiums for every 1 chromate so that the charges balance out. Now, when I rewrite it, I can eliminate parentheses that aren't needed. If you have only 1 chromate, there is no reason for parentheses. So the final answer is Na2CrO4. Okay, looking at these examples, iron 3 sulfate, that means I have iron with a 3+ charge. Sulfate is SO4 with a 2- charge. Look to see if the charges cancel. A +3 and a -2 don't, so cross the charges. This 3 is rewritten down here, the 2 is written down here, and the formula is Fe2SO4 3. Next example, potassium 1+, nitrite NO2 1-. Look to see if the charges cancel, and they do. So if the charges cancel, you have one of each ion. We also do not need the parentheses, so it just becomes KNO2. For magnesium chloride, magnesium has a charge of 2+. Chloride has a charge of 1-. Those charges don't cancel. When the charges don't cancel, we cross them. So 2 by chlorine, 1 by magnesium, and you get MgCl2. For calcium hydroxide, calcium has a 2+ charge. Hydroxide is OH, but with a 1- charge. Charges do not cancel, 2+ and a 1-. If the charges don't cancel, cross them. And we get CaOH2. Parentheses must be kept because we have 2 hydroxides. We need to keep that together and make sure everybody knows that that's 2 of everything in the parentheses. Next example, aluminum phosphate. Aluminum has a 3+ charge. Phosphate is PO4 with a 3- charge. Look to see if the charges cancel. 3+, 3-. They add up to 0. They're the same but opposite, so they do cancel. And that means one of each and no parentheses needed, so AlPO4. Lead 2 chromate. Lead 2 is Pb2+. Chromate is CrO4, 2-. charges again cancel, no parentheses needed, one of each ion, and it's PbCrO4. Okay, that sums up writing formulas. The biggest thing when writing formulas for ionic compounds is you must have your ions memorized. You must know where they are, at least where to find them. In the next section, we'll take a look at naming atoms.